Hello students. In this last part of the course, we're going to focus on another mechatronic system. It has some similarities to the HAS200 and some other new things that are a little different. This is called the EETMECH 100 system. It's a capstone project that we've been working on for the last several years with students. Every year the students make additions, improvements, enhancements to the system. And the purpose of this system is to sort colored objects. We're using Lego pieces because they're uniform. And I'm going to be going through all the different components of the system, and then I'll give you a demonstration of how it works. So the mechanical moving parts of this system consist of a linear actuator. This long object here is a linear actuator. It's driven by a DC motor and is coupled to a lead screw by way of a belt. So this will move the arm in either direction. And then mounted on the end of the arm are a couple of pneumatic components. There's an actuator that moves up and down, and another one that operates a gripper. And that enables the arm to go out and grab a Lego. There's also a conveyor belt, which is designed to move the part down the conveyor into one of the slots in the bin, sorting bin. So when it's operating, you'll see that. There's also a color sensor right here, which senses the red, green, and blue content of any object that's held up to it. And based on those red, green, and blue readings, they're interpreted by a microcontroller on this board, and then the PLC is signaled as to which position to place the part. So there's a microcontroller to drive the color sensor. Then working backwards from the motor, the DC motor has two wires. It's a basic permanent magnet DC motor, so it just needs the two wires for control, but it also has an encoder that counts pulses as the motor turns. So the encoder signals and the motor leads are brought back to the motor interface. So it looks kind of like this. It's got a series of connections that go out to the PLC, and these are the connections that go to the motor and the encoder. I brought one out that has nothing wired to it so you can see what's in it. It's basically an H bridge and then some transistors to take the 5-volt signals from the encoder and translate them into 24-volt signals for the PLC. So that's just to enable the PLC to drive the motor. So now working from the other side, this is the main power receptacle, which is taking 120 volts AC from a standard wall outlet, and that goes to power up a DC power supply. This is a 24-volt DC power supply. There's also a 5-volt power supply, which is used to power the microcontroller board. Then the PLC, the inputs on this side, the outputs on this side. Then there's an Ethernet module to connect the PLC to the HMI over here, and also to provide a connection to PC for programming and loading programs. And there's a terminal block. Then there's a unit here where the solenoids, there's only two pneumatic solenoids that are being used. So they're wired from the PLC in here, and that connects to the solenoid valves, which then drive the gripper and the linear actuator to move the arm up and down and operate the gripper fingers. So I mentioned the HMI. The HMI allows us to have control, manual control over the system, and also goes into an auto mode, which I'll demonstrate. So if I want to move the actuator back and forth, I hit these forward and reverse buttons. I can also change the speed of the actuator. This entry here is a PWM duty cycle percentage. Right now it's at 10%. If I make it 50%, it goes that much faster. Even 100% would be the fastest. Okay. I like to keep it down at 10% because it's a nice controllable speed. And we can also run the conveyor from here. And that's set at 40%. That's also controllable by PWM. I have it at 40%. Seems to be about the right speed. But that'll run, this would be full speed for the conveyor. Put that back down at 40%. We also have controls for the pneumatic components. So the gripper up down is, we have buttons for that, and then I can open and close the gripper. So if I move out to the far end of the actuator's extreme, I can go down, close the gripper, go up and move back, and now I have a part. And if I want to place it on the conveyor, I go down, open, up, and now it's on the conveyor. I'll put it back on the platform. So I'm going to demonstrate it in auto mode, which means it'll automatically keep going out to the platform to pick up a part. Now, one of the things, as I mentioned, this system is in development every year. So last year, the main project was to get the conveyor and the conveyor motor installed. The next phase of this project would be to create an automatic part feeder. But at this point, there is no automatic part feeder, just a platform. So I'm going to have to keep manually putting the parts in as the system is running. So I'm going to start it up, and you'll see the whole process as it starts picking up parts, brings them back, color sensor lights up, senses the color, and then it's RGB, so red, green, blue is the order that the parts are put in. So I'll let it run to the point where you can see some of the parts starting to go down into the bins. Okay, so that is what the system does. What I'm going to do now is I'm going to go through the electrical diagrams, and we'll start like we did with the HAS200. We'll start with the power diagram, talk about the power distribution part of the system, and then we'll work our way into the inputs and outputs, the interface with the pneumatics, and also the pneumatic diagrams as well.